Hey, everybody. Hello, good morning, and welcome to today's webinar. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and today the topic is AI-augmented coding isn't your robot overlord. Before we get started, well, first I'll introduce Matthew Lodge, who's right next to me here. He's the CEO of Diffblue, which is sponsoring today's webinar. How you doing, Matt? Thanks for being here.
Thanks, Dave. It's great to be here.
So before we get started, I just want to let the folks know that we'll be taking live questions throughout the event. And if you have one, just type it into the chat area and we'll answer as many as time allows. Secondly, this is going to be recorded, so you can play it over and over again to your heart's content, share with your friends, colleagues, whatever. And that will be available starting tomorrow on sdtimes.com. So as we've reported over the years in SD Times, developers have had a real love-hate relationship with AI. They acknowledge areas in which it can help them, but of course there's always been that fear of AI making them obsolete and replacing them in their jobs. But fear not, because today Matthew is going to talk to us about his company, which is Diffblue, and how AI can help reduce developer and DevOps bottlenecks and leave the innovative work to developers. So I'll let Matt elaborate on that. So take it away, Matthew. Thank you.
Great. Thanks, Dave. All right. So we're going to talk about AI-augmented coding, how it isn't your robot overlord. And essentially, this is the stereotype, right? So we're going to replace programmers with robots. And as this tweet says, clients will have to accurately describe what they want. We're safe. So, of course, AI-augmented coding is a long way from the dystopian future. What we're going to talk about today is what is AI-augmented coding, and that includes a couple of demos of tools that you can use for AI-augmented coding. So these are free things that you can try today yourself. Secondly, we're going to look at the different approaches that are being made. So how does the technology work under the covers? And because that also tells you what kind of code it will write, right? So there are different machine learning and AI techniques that are being used to deliver these different products. And then we'll talk about what it can do for you. So how can it take mundane but vital coding tests? How does it automate that? How well does it do? So that you can focus your time and your attention on the more interesting stuff. So AI augmented coding is these sort of artificial intelligence techniques, but principally machine learning, to help developers write code. And especially the boring, repetitive code that's tedious to write. And because it's tedious to write, it's error prone. So things that we find boring, errors creep in. We make more errors on boring stuff. So the state of the art today is essentially there are three main categories of AI augmented coding. The first one is auto completion, which has been around for a few years. So Tab9 and other companies started offering smart autocompletion, so way in advance of your sort of standard IDE autocomplete, which is more sort of syntactic, by basically figuring out what it is you're coding and giving you the next chunk of code. And of course, the bigger player in the space, or the larger player, is GitHub through GitHub Copilot. So that's a combination of OpenAI's model, which Microsoft invested in. So Microsoft put $1 billion into OpenAI. And that's available in GitHub's offering, GitHub Copilot. So we're going to demo Copilot a little bit later on. Second area, and I put this in here because it's Google or Alphabet that's behind this, and this is coding competitions, right? So AlphaCode, which we'll get into later, was a automatic coding system that was designed to win coding competitions. So we'll take a look at that. And then there's unit test writing as another category, and a couple of products here. Obviously, our product is here. This is what we do. There's also an open source product called Evo Suite, and another company called Ponycode that's now part of Circle CI, does something similar. And what you can see here is that the auto-completion of the coding competitions, the underlying technology is based on a thing called a pre-trained transformer, and I'll get into what that is in a second. But you might have heard about GPT-2 and GPT-3. There will, of course, be a GPT-4. So there's a generalized pre-trained transformer models, and I'll explain what that means in a second. And in the unit test writing area, everybody is using reinforcement learning. And so I'll explain why there are these different techniques being used because different techniques are better for solving different problems. So let's start out with GitHub Copilot. So Copilot's based on this notion of a thing called a transformer. They are the new hotness in machine learning for language today. And transformers are machine learning models that iteratively predict output tokens from input tokens. That sounds very sort of generic. What do we mean by tokens? In the case of natural language, tokens basically correspond to words. So you think about the quick brown fox being 4 tokens. So the transformer under the covers taking an input set of tokens and translating those into an output set of tokens. In the case of natural language translation, this example here, you iteratively run this through the transformer and it starts to convert the English into French, right? So you have the quick brown fox and turning into le renard brun, right? And the way that this works in the transformer is that the transformer is a form of machine learning that pays attention to the significance of different parts of speech. So context. And that's what's made transformers so successful. It's part of the reason that transformers have been so successful is because they can do a better job by they take into account context. Previous attempts at solving this kind of thing, it was just like a bunch of words in a sequence, but you didn't really know, well, is a word a verb, is it an adjective, and so on. And transformers essentially use that additional information, and that's one of the reasons why they do a better job. So generative pre-trained transformers, there are the most famous, I would say, are from OpenAI. So GPT stands for generative pre-trained. So that's a model that's been trained on an existing corpus, a collection of inputs of text, and in the case of Codex, programs. So GPT-2 was an open source model. So the data, the actual model itself, you could download it, you could look at the code, you could, if you wanted to, train it yourself, produce the model, but they also gave you all of the weights, basically the final state of a trained model. And this came out in February 2019. 1.5 billion parameters, that's the size of the model, the statistical model that you run to do inference. So when you want to run GPT-2 in order to make a prediction, translate some text or summarize the text, answer questions, that's the size of the statistical model that you're running. 1.5 billion is big in context of thinking about, for example, image recognition. So image recognition, the biggest model, the model that Microsoft ResNet that's used to do image recognition, it's more accurate than a human at doing image recognition. It's about 10% of the size of that. So think about that for a second. Right? So these are much, much bigger models. And in GPT-3, from July 2020, so just over a year later, came out, it's 175 billion parameter model, so massive by machine learning standards. It's not open source anymore, it's a closed source proprietary model and proprietary data. And GPT-3 is more capable in terms of what it can do. So it can summarize tests and answer questions about text. It can also generate or write new text from an input. And it's that last piece, writing new text from an input, that forms the basis of auto-completion tools. So Codex, which is a very specific model that's designed to write code, is based on GPT-3. So the same model, same source code, but trained on different things and tuned for code writing. So Codex came out, or was announced, I should say, in July of 2021. It's smaller, right? It's a subset, if you like, of the GPT-3, 12 billion parameters, and it writes boilerplate, repetitive code, and it's really good at calling what they call, say, calling foreign lands, so writing foreign API calls. So I'll get into each of those in a second. So Copilot is trained from 54 million public GitHub repositories. That forms the training and the test set for Copilot. There was some controversy about, does GitHub have the right to do this? Some open source people got very exercised about the, using their source code to then generate some other code. Was that within the license? I'm not going to talk about that because I'm totally not qualified. That is a whole other presentation. So we're just going to talk about what Copilot can do and how it works. So 54 million public GitHub repos go in to train the model. There's a test set. You divide your data up into two, so you want to see how good the model is. And at the end of this training process, you get a 12 billion parameter model. It's very expensive to train a 12 billion parameter model. I don't know how much it costs to train Codex, but we can guess we're talking millions of dollars to do that. So Codex, is, because it's 12 billion parameters, it runs in the cloud because it's a massive model. And so what is happening when you are typing in your IDE is that content of your IDE is going up to GitHub, to the Copilot service. On the back end of the Copilot service is the Codex model, and that is generating suggestions for completions. It generates multiple suggestions. We'll see that when we get into the demo. And you decide what the best completion is. And how you use those completions is then fed back into the tool to help improve it. So your source code is leaving your IDE, going up to GitHub. And so for organizations where that is not possible, or it's not something that fits in with their security requirement, then that's obviously not something you can do. But just for your own code at home, it's perfectly fine. The other advantage of this, of course, is that because that's a big model, somebody else is paying to run it, right? So it doesn't cost you anything on your local machine in order to make use of that model, and it's very fast because it's got a lot of resources, and we'll see that in the demo. So according to GitHub, Copilot works great for quickly producing boilerplate and repetitive code patterns. So what do we mean by that? So in Boilerplate, here's an example. So everything that's got a blue background here has been suggested by Copilot. And the text at the top was the input. So you've got a very important comment here that Copilot is keying off. So the comment says a person class with a name and age accessors and an equals and a hash code. And then they start typing public class person, open curly bracket, and then Copilot suggests the rest. And so it's been looking at class with name and accessors and equals and hash codes, and it's transformed that into a suggestion of a completion where it has done all the boilerplate. It's like, okay, here's a class of person, they've got a name, they've got an age, I've got a constructor there, and then I've got a bunch of accessors and things like that. So good example of the kind of code when you're starting a new class, all the usual things you would need to do, you can just automate that process. And even if it's wrong, then it doesn't matter. You can pretty quickly fix that. So Copilot does not try to be right all the time. And in fact, transformers as an approach are generating potential solutions to this, but they have no idea if their solution is correct. They are just making an association from the input and creating an output based on their training. They don't understand anything about the program. And so it's the training process that makes them so good and makes them so useful, right? So most of the time they're suggesting things that are, if not exactly correct, then close to being correct. So GitHub's done some testing. They say about 43% of the time with Python, Copilot will generate exactly correct code. Another example here, and this is something where you're calling an API in another system, often another cloud system. And when you're doing that, you don't use that API very often. So you probably go and look at the documentation. You might Google, you might go on Stack Overflow for some examples of that. And you're trying to sort of patch together maybe a bit of cut and paste from another example from Stack Overflow. And then you find out it was from 2012 and the API has changed. And so you need to find a different answer that's more recent. All of that stuff goes away. And in this particular example, you can see what they've done here is package main, create an API key, a structure for tweets, and then fetch tweets from user. And then Copilot suggests the completion here, which goes out and calls the Twitter API. So again, even if this is not exactly correct, and by the way, this is correct, but if it wasn't exactly correct, it's close enough, and it gets you something to get you started, and it does that very quickly. All right, so let's take a look at Diffblue cover. So test writing is what Diffblue cover does. It writes unit tests, and that is a much harder problem than completion. And part of the reason for that is you need a lot more context in order to write a test that actually works and gets good coverage. So you need to know a lot more about the program, and you need to know a lot more about the data, and you need to understand things like coverage. And it is also most valuable when it's 100% autonomous. So we said before, Copilot's exactly right 43% of the time. You just don't know which 43%, which is why it is positioned as something that sits alongside a human and helps the human be more productive, but it's not trying to be autonomous. Test writing, you need to be autonomous. You want to have a full set of unit tests for the entire program. That is the most valuable thing that we can do as a company with this product. And getting there means there are some fairly complex interdependencies between the program and the data. And then there are practical difficulties, things that aren't in the source code. So things like frameworks have certain conventions. There's the notion of inversion of control in a lot of frameworks, particularly in Java land. So, with Spring Java and Google Juice and lots of those frameworks involve inversion of control. So just looking at the program doesn't tell you enough in order to be able to write a test. You need to know what the framework does. So there is lots of sort of practical difficulties there associated with writing tests. So the way that we think about this problem and the way that our product works is as a search of program space. So reinforcement learning has been very successfully used in lots of different applications, for example, for playing games. So Google AlphaCode, for example, uses reinforcement learning. And reinforcement learning is a great technique when the overall space to be searched is too big for you to do that through brute force. You can't look at every single possible solution in the space. In the game of Go, there are more possible solutions than atoms in the universe, stuff like that. Same when you're writing test programs, the number of possible test programs is essentially exponential. And so we think about it as a way to conduct a smart search of that space. So we're looking for inside of the set of all possible test programs. We want the set of programs that are valid and run, that generate high coverage, and that developers find easy to read, right? When a test fails, you need to be able to look at the test, figure out what it's doing so you know what to do with that. And that is essentially what Diffblue cover does. That's how it works. So under the covers, what are we doing is we're writing a test, and then we run it against the code, the method under test, right? So if we go through a class, we look at all the methods, identify which ones are testable. We write a test, we run it, we look at the results. So what kind of coverage did it get? Did it throw an exception? A bunch of other feedback that we get from the test. And that goes in along with the existing Java code, enables us to predict a better test. So we try that test against the code under test, see what the result is, and we keep going. So we're essentially refining our test. So as we conduct this search through the program space for the test that gives us the best coverage and the best outcome. And essentially, the idea is it's called probabilistic search, where you look for solutions in the area most likely to have good solutions. So you're not guaranteed to get the best solution, and that's not the goal, because the only way you can get the best solution is to look at every single possibility. But you are going to get good solutions out of this kind of approach most of the time. So what this means is that Diffblue cover writes what we call regression unit tests. So you can write tests for the entire application, so you get a baseline of tests. So what does the code currently do? And the advantage of those tests is that you can run them against new code, so changes to the code. So adding, taking something out, refactoring, all those things, you can run those tests against that. And failing tests can indicate bugs. They indicate changes of behavior. They could also be deliberate changes of behavior, in which case you need to update the tests, and Diffblue cover does that for you automatically. You can tell it to update the tests, and will rewrite the tests that are affected by a particular code change. So in terms of a Git-style software change process, you've got your running code, you write a code change, you create a pull request, and at that point you run all the unit tests against the PR, and based on the results you decide, is this change correct? And if it's not, then you go back, update the code, rerun the tests and so on, until you get to the point where everything is fine and the PR is approved. So a Diffblue cover, from the working code, we're going to write that test baseline. right? So we can go take the entire project, write a full set of tests for that project. And so then when you have the create the pull request, you can run the Diffblue tests alongside any other tests that you may have written, so human written tests, and look at the test passes and failures to figure out is the change correct. The other thing that Diffblue Cover will do for you is that it can shorten your test time by only running the relevant unit tests. So one of the things we know when we analyze the program to write the test in the first place, we know which lines in the source code are covered by which tests. And so from the PR, we can look at the deltas, the changes, and identify which tests reach those lines of code and just run those and don't run the rest. So we can also dramatically reduce the amount of time it takes to run CI. So you get some test failures, and test failures could either be you broke something you didn't intend to, or it can be intentional. And then after that, you can update the Diffblue baseline with the new tests. And again, that's incremental. We know which tests need to be rewritten for any given PR. We just rewrite those. So it's very fast. So Cover is good for 100% autonomously writing unit tests and then doing the same thing around test maintenance, right? So you can build a baseline and the tool will maintain that baseline updated over time. If we can't write a test for a particular section of code, we'll give you a skeleton, including all of the mocks. So for example, we might not be able to write assert statements in our test. We can't assert the return value. Often we see this a lot for things where there is no accessor for us to look at the return value in the object. And so we can write you a skeleton test with a to-do in there for you to take that and turn it into a full test or make the code more testable. We also give you a dashboard for reporting on what kind of coverage we get, what coverage did we get versus existing tests, which code is untestable, where's the highest risk and complexity in a project. All right, so at this point, I am going to stop sharing slides and I'm going to switch over for a live demo, which is always the fun part of doing any of these. So I am going to attempt to share IntelliJ. There we go. So for this demonstration, I'm going to use Spring Pet Clinic, which is a Java application. So Pet Clinic is an example application that's part of the Spring framework. It implements a fictitious vet's office. And so you can here's an example screen. So it's a web application. So if you build it and run it, you get to a screen that looks like this. And so you've got lists of owners and their information and their pets. And right up there in the big green box, it says you can click on this to find owners, right? So maybe somebody wants to book a new appointment, and so they want to, find the owner. So that is the example that we're going to use here, and we're going to look at it because it gives us a couple of opportunities to try using both of these products and see what they do. So if I close down the README, you can see that Pet Clinic is a classic sort of model view controller application, and so I have some models here. I have an owner. So I have an owner itself, the object for the owners. I have owner controller here, and I've opened the owner controller Java. And I have a thing called a pet, and there's a controller for those and so on. And so, pets are, things like, birth dates and type and all of those, all the usual things you would expect with something like this. And so let's take a look. And let's write some new code. So we're going to write a new Java class, and we're going to call it dog. So we're going to have a new pet. We're going to create a dog class. Maybe we need to do something special for dogs. And so here we are in IntelliJ, and Copilot has already suggested that the dog class extends pet. I was like, okay, so it knows that dogs are pets. So that kind of makes sense. So I'm gonna hit tab, and I'm gonna take that, and now it's suggesting another completion here, and I can go over, and you can see here are the alternatives, right? So the transformers generate lots of solutions. We'll come back to that a little bit later on, but here you can go. We've got some boilerplate that is generated here. I kind of like this one at the top here. So now I've got a dog, and I know what breed of dog it is. Unfortunately, this code is wrong. So there, you can't feed name into super. So I'd have to do something like that to fix that. But you get the idea. So very quickly, I can get the boilerplate for this particular test, this class, not for a test. And I can, if I was smarter about this, if I decided that I wanted to, extend the dog class, I could start typing in other things here and it would suggest more completions. But you get the idea. And so this is a really good example of boilerplate. So let's just delete dogs. And instead, why don't we do a cat? So let's say cats are special. Right away, we can see here, we get something slightly different for cats. And we get cat extends animal. The only problem is there is no animal class. And this is a really good example of transformers of the strengths and weaknesses. Now, we saw that with dogs, it was actually pretty good. And it got us some useful boilerplate pretty quickly. But when it comes to cat, it doesn't know anything about the program. And there is no class called animal. So that's not going to work. And it's a good example of how transformers work. They are guessing at what the output should be based on their training and the amount of input text. And we didn't give this one a lot of input text beyond cat. But it is crucially not using information about the rest of the program in order to do this, which is why it's trying to extend an animal class that doesn't exist. So that gives you an idea of some of the strengths and weaknesses. So when it works well, it works well. Sometimes it doesn't work so well, and that can be a bit annoying. Right, so we're going to delete our cat class, not very useful. Instead, we're going to go to owner controller. So remember, if we said at the beginning, like on that website, there's a big green button that says search owners. And here is the code, the Java code for processing that search. This is a Spring application, so here we are with the appropriate Spring annotations. And we're going to process the find form. So you're going to type in the name of an owner. And we have some fairly typical logic. Here we say, well, if there's just null being passed in here, we set the last name to be empty, because that can happen. And then we've got some logic, and we've basically got 3 branches here. We've got, if we didn't get any results, then we just go back to the search form. So that's the URL is returned here. The second one says if we get exactly one result, we just go straight to that result, right? So we don't present a list with one item in it. We just go straight to that owner. And if we've got multiple owners, then we go to a page with the list of owners on it. So pretty straightforward. And so let's take a look at how we can generate some tests for that. So in Diffblue cover, what I do here is I can just click on this Flask icon at the side, and I'm telling cover I want tests just for this particular method. I can also have a set of tests for the entire class in the IDE implementation. So I can go to owner controller, I can right click on it, and I can do my write tests here instead, and I would get tests for the entire class. So the IDE is designed to, the IDE plugin is designed to run interactively, so it's a class at a time. And then if you bought Diffblue cover, you can run it against the entire project. In fact, you can run it against every single line of Java code that you have. So the command line is designed for large-scale test writing. It's something you can integrate into a CI system so you can automate that process, or you can just run it on your laptop. And the other good thing about reinforcement learning as a technique versus transformers is that reinforcement learning requires far less CPU and memory. So the minimum requirements for Diffblue cover are 2 CPU cores, 8 gigs of memory. The more memory you give it, the better it will go, the faster it will go. But that is very, very different to running a 12 billion parameter machine learning model, which requires significantly more resources. And that's why you want to run stuff like that in the cloud versus on your own laptop. So Diffblue cover here is running on my computer here, right, is not running in the cloud. It is completely local, and it's finished already. And so we created 4 tests for this find form. And in Java land, they live over in the test area. So let's take a look at what we've got in here. And so here are our tests. And these are so this is the code that's been written by Diffblue cover. And so what we can see here is that we have all of the appropriate Spring stuff here at the beginning for tests. And here's the first test. And so the first part here is we do the mocking. So we don't want to be actually calling the database to get information about owners. And so what we say is that when we do find by last name, we're going to give back the empty array list, right? So we're just going to create a new array. That's what's going to come back. And so then here's the actual test. So we're using Spring, so using mock MVC builder. So all of this infrastructure is built into Spring. And so we build a request, and we expect to get an OK back and size 1 and go back to the find owners page, right? So that's the first set of code that we looked at, right? So it gives the empty array, which triggers that if statement so that we get an empty string to search. And then we expect to go back to the original page. So that's the first branch. Second branch is when we get exactly 1 owner, if you recall. And so here what we do is we create an owner object, and we add this owner to a list, and then we return that list for the find by last name again, right? So we've set up our mock here to return exactly 1 owner, and Jane Doe, who lives at 42 Main Street in Oxford, obviously, being a company from Oxford, and she has her telephone number. And so what we can see here is that what we expect to get back, we're asserting that we get exactly 1 owner back, size 1, and we get redirected to the page for that owner. So that's the second branch that we saw there. And then the third branch is when we had more than 1 result. And so you can see we're creating 2 different owners here. Guess what? We're going to add both of them to a list and return those, and you get the idea. So we've got a set of tests here, and then there's another one. There's another example here that where we are setting a result for finding another owner, but I'm not sure what is going on in that test. But it's a case I didn't realize that we had in that particular logic. So that's the other advantage, is that often Diffblue cover will cover cases that you didn't think about. It's probably the exception case, I'm guessing. So you can see that we get a full set of tests that get all of the coverage for that particular model. And it was fairly painless to do that. We just clicked on this. We write tests. It takes about 2.5 seconds to write a test in Diffblue cover. So let's stop the demo here. And what I'm going to do is just switch back to slides, because we're going to talk about DeepMind AlphaCode just to wrap up here. So DeepMind AlphaCode was announced in a sort of blaze of glory in February. And so you got headlines like this: 1 step closer to autonomous coding. Is AI ready to replace programmers? No, AI is not ready to replace programmers. Don't believe the hype. Let's take a look. It is very interesting, but it is not your future robot overlord. So AlphaCode is also transformer-based. And in this particular situation, they set it the task of trying to win public coding contests. And so training looks slightly different to what's going on with Codex and GPT-3, in that you've got the problem statement and code that has been written by people who enter these competitions. So the database of entries and the correct set of winning entries, so entries that satisfy the criteria, are publicly available, and it's been trained on that. Same kind of thing. It's a transformer model. It's a very large model. And crucially, they also use the unit tests. So in coding competitions, you get the problem statement, and you get a set of unit tests that have to pass, right? So your code has to pass the tests. And so you can use the unit test for validation in the case of AlphaCode. So how does it work under the covers? So what it does is it takes that description from the programming competition, which is obviously very well worded, it's clear, it's unambiguous, exactly what it is that, what's the code that we want in this for this competition, feeds that into a transformer, which then generates hundreds of potential solutions. And I showed you in Copilot that, on the right-hand side, we had the, list of, Copilot gives you up to 10. In AlphaCode, you get hundreds of programs that are generated by the transformer, but we don't know which ones of these actually solve the problem. So I remember we talked about that in the case of Copilot, same issue here. So Google does a very clever thing. What they do is try to reduce the number of candidates, because they realized a lot of the programs they generate, although the text, the source code is different for these programs, semantically they're the same thing. And so they do semantic analysis of the programs, and then they can do cluster analysis on that and find out which programs are semantic duplicates, because they'll be in the same cluster in the space of semantic solutions. So they filter all of those out. So what they do is they pick one from each cluster to be representative of all the programs in that cluster. That gets you down to tens. And then they run the unit test against those tens of potential solutions, right? So they take the unit test as an input here, and they use that to filter it down and then pick a final winning solution. So it's a very interesting approach. It has some similarities to what we do with reinforcement learning in Diffblue cover, in that it generates many potential solutions to the problem and then attempts to choose the best one. So it is somewhat like reinforcement learning in that way. So AlphaCode is good. It beats 46% of programmers in coding competitions. So I guess it's average by that measure. But I think it's really interesting as a demonstration of what could happen in the future. It's not a practical solution today. It's not something you could use, largely also because it's not available outside of DeepMind, but also it works in a extremely well documented and very accurate area where you've got these great descriptions of exactly what program you want to have and exactly how it works. And crucially, you have a set of unit tests that can tell you whether or not your program does the right thing. So in those kinds of, that's a sort of rarefied atmosphere. And of course, your average programming development job is just not like that. You don't have a clear and accurate description of what it is that every single piece of code is supposed to do. In a lot of cases, you don't have a unit test either. That's why we wrote Diffblue cover. So my summary here in the last slide. So AI-augmented coding tools are real, and they can help you eliminate tedious, error-prone coding tasks. And all of the leading tools are free editions. You can try Copilots in technical preview. You just need to sign up for that, and then they send you an email when you come off the wait list. Cover, you can just download a community edition either from JetBrains Marketplace or from our website. And we're just getting started, right? This is a new area. There are useful tools that are available today, but there's a lot more that's coming down the line. So get ready and buckle up. So I'll stop sharing my slides here. And then Dave, I think you wanted to, you had some questions.
Yes, indeed. Thank you, by the way, for that presentation and demo. Very enlightening. I think perhaps you were able to allay some fears of developers about them losing their jobs or what have you. But one of the questions that I had for you before we start taking the questions from the attendees, again, if you have a question, type it into the chat and we'll get to as many as we can. But the question I had was this. So you and I have spoken in the past about testing being one of the big bottlenecks of DevOps. Yeah. And how automation can really kind of reduce those bottlenecks in a way. So who are these tools actually benefiting? Is it benefiting the developers, or is it actually a business decision that helps the developers, go faster, be more innovative, produce more, release more with less risk? Where is the value?
Yeah, well, it's both, right? So for developers, obviously the productivity benefit and helping you get out some of the drudgery is a main thing, but also that's also good for the business. I mean, the business wants you to write code and advance, what the software does. That's what is important to the business, and frankly, also retaining highly paid developers is part of what most organizations want to do, right? They want they want your software development job to be interesting. They want you to enjoy doing it. They don't want you to have productivity blockers. And you also get into some of the, for business folks, they also have to think about things like risk and what's the risk in my code base and how well tested am I, and be able to make some of those trade-offs. Sometimes regulators are interested in that kind of stuff. So there's benefits to both.
Right. No, that certainly makes sense. So another question that I had is, how is automated unit testing? How does that fit in with test-driven development?
Yeah, that's a great question. So we do a developer survey every year. So last year we asked that question. We asked it in 2 different ways. We're a bit sneaky, I'm afraid. So we asked folks, how many of you do test-driven development? And then later on the survey, we said, how often do you write the test first? And a lot of people said they did test-driven development. Only 8% of the respondents in the survey, and this was over 300 developers, said they write the test first. And so when we talk to people about test-driven development, what they mean is they write the test and the code at the same time, because it is very, very difficult to write the test before you've written a line of code. Because there's a certain amount of understanding that comes from as you write the code about how to solve the problem, how to structure it, what does the API for whatever it is for your thing look like. And if you've made assumptions about that when you wrote the test, that they're just not going to be true when you start writing the code. And so that's part of the challenge. So something like this works alongside it, because we're not saying humans should never write another test again. And humans obviously know exactly what the code is supposed to do, and writing that kind of test is important, but you don't have to write you don't have to write 100% of the tests. And so this is something that can help you, and it can write the bulk of the stuff, especially, again, all of the boring stuff that you still need to do, like testing all the setters and getters and testing of the logic of the application. All of those tests have to be written, but as a developer, you don't have to write all of them.
Great. So one of our attendees has written a question to Dorai. Is this only for Java? What about Node.js or Python, for example?
Yeah. So Diffblue cover is only for Java today. We intend to do other languages in the future. Copilot supports quite a broad range of languages. So Python, Java, C, C++. There's varying degrees of coverage for those different languages. Go. So JavaScript. So there's more coverage in the transformer model because it's been trained on more languages.
Gotcha. Okay. So another question was, you say that the product is autonomous, but we only saw it working in an IDE. So I'm guessing there are other options there. Or?
Yeah. So the command line version, so it's exactly the same capability, but wrapped up in a command line is something you can run. You can basically CD into the directory of your project and just run dcover create, which is the command, and it will just go off and write tests for the entire application. So that's the autonomous piece, and it figures out where they should go in your project, and it creates them. And then, if you're using Git or something like that, you can see with the Git diff, you can see all these new files just showed up with all my tests. You can run them with Maven or Gradle in the Java world. So that's where the autonomous piece comes from. And then there are a couple of modes on the command line to do incremental testing. So, for a given Git diff, what tests need to be, just rewrite the tests that need to be changed as a result of this code change, right? So the code has changed, so the tests need to change, but you don't need to worry about all the tests. It's just the ones that are affected by this request.
Perfect. So I'll put out a last call for questions to our attendees. And we'll, see what they have. But in the meantime, so here's another question that I had. So if in fact testing is the biggest bottleneck in DevOps, so why isn't everybody automating at this point? Is it really is it a question of trust? Do people not trust AI to do what it's supposed to do? Again, does it go back to the fears that developers have? What's holding up the world from just assuming that we're just going to do automated testing?
Yeah, well, I think that's certainly the case. There are certainly a lot of questions for developers. So a couple of things. And then I think the other thing is that when I do a demo, a lot of times people don't believe that stuff like this can be done. And so that's part of why we did this here, is like this stuff really is real, and it is good enough that you could use it day to day.
Mm-hmm.
And so it's also part of the reason why we and folks like Copilot do, a free version, because so you can see for yourself.
Right.
It's a relatively new area, and the companies in this space are just getting started. We've only been around a couple of years. There are some up and coming competitors in the space, so I think that's part of it. The newness is part of it.
Mm-hmm. Certainly makes sense. So when you move to automated testing, let's say, how much at the beginning are people diving in and double checking and make sure everything executed the right way, and how long does it take them really to get to a point where they can just blindly say, okay, we've double checked it enough, when we've dropped in, everything seems to be working, so that's one less thing for us to think about now. How long does that take usually?
Yeah, it varies. So I've seen it happen in days. I think the record is 3 days.
Wow.
And it depends on the complexity of project and what's your risk tolerance. Different organizations think about these things differently.
Right.
But it's been in the early days, everyone's looking at the test like, what did it write? And like, do I understand this test? Does it look like something I would write? We spent a lot of time and we applied for a patent on this, is writing code that looks like a developer wrote it.
Mm-hmm.
Because it's very important the developers be able to look at the code, understand what it does. It should be idiomatic. It should follow the conventions of the language and the framework and so on.
Right.
So that's that's part of it.
Right.
And I think that that is a really important thing to focus on to answer that question.
Yeah, no, that's fine. And what about the models for that? Is there a lot of training involved for people to create the models, or?
So there's no training involved. If you can write code, you can use these products. It's very straightforward. In the case of Diffblue Cover, we're using reinforcement learning, which is a real-time learning technique. So it learns as it writes the code. So it's learning from your program what works and what doesn't work as it writes tests.
Great.
And so it's the other model is the pre-trained, right? So they have to be trained on a large corpus of code, a large bulk training, and it's just different types of machine learning. So it's essentially it is just the difference in the techniques and the difference in the approaches, and they're good for different things.
Right. Excellent. Well, Matthew, thank you so much for your time today. Certainly appreciate the very informative presentation and the demo. I'd also like to thank Diffblue for sponsoring today's program. Thank you very much. And of course, thanks to our attendees for hanging in there and listening to us. As always, we appreciate your time as well. So for now, again, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.
Thanks, Dave.